Welcome to the video lecture on digital electronics. In this video lecture, we are going to discuss about the complements of a number system. So first we will see why do we require complements, and then we will move to the different type of complements. Basically there are two types of complements, and at the end we will see how to find the complement of a each number. So there are four different type of number systems, and we will see how to find the complements for each number system. So in the first we will see what are the uses of complements and why do we require complements, right? So let me write down. Complements are used to, first point, it is used to represent negative numbers. So basically the complements are used to represent negative numbers. So second thing is it is used in subtraction operation. So there are two important uses of complements. The first one, it is used to represent negative numbers. The second thing is it is used in subtraction operation. It simplifies the subtraction operation, right? So for example, let us see. So in order to represent a negative number, we use a minus sign. If I say a negative 10, that is written as minus 10. But the digital circuits cannot understand the symbol. So for this reason only, whatever the negative numbers you want to represent for digital circuit, that is represented in complements form. That is represented in complements form. So this is the first use, and the second use is it is used in subtraction operation. So let us see, I want to perform a subtraction between two numbers a and b, that can be represented as a minus b. So this can be further written as a plus minus b. As we already said, minus b is the negative number, so it can be represented by finding the complement of b, so that it can be written as a plus of complement of b. So if I find the complement of b, that gives the negative of b. So if you observe the last line, so actually I am doing the addition, but I am getting the result of subtraction. So that means with only one operation, that is addition, we can perform the addition operation as well, and we can perform the subtraction as operation as well by providing the complement of b. So that with only one type of operation, we are able to find two types of results. So that you can do a plus b as well, at the same time you can do a minus b as well. So these are the two important uses of complements, right? So by using these two complements, in the further classes we will see how to do the subtraction operation by using complements only. Well, the next thing is how many types of complements are there? So basically there are two types of complements. There are two types of complements. So one is called diminished radix complement, also known as R minus ones complement. So the first type of complement is called diminished radix complement, also known as simply known as R minus ones complement. The second type of complement is called radix complement. So that is also called as R's complement. So basically there are two types of complements. You can calculate it for any number system. So far we learned four different type of number systems: decimal, binary, octal, and hexadecimal. There are four different type of number systems. For any number system, we can calculate two types of complements. One is called r minus 1's complement, also known as a diminished radix complement. So the second one is called r's complement. So if the number system changes, the value of r changes, and based on the number system, there are two possible complements for each number system. So let us summarize that. Number system, r minus 1's complement and r's complement. So here r represents the base of the number system. So we know that for the first number system we learned is a decimal number system. So for decimal numbers, the r value equal to 10. So that my r minus 1's complement or my diminished radix complement is nothing but 9's complement, and my radix complement or r's complement is equal to my 10's, 10's complement. In a similar manner, for binary number system, for binary numbers, my r minus 1's complement is nothing but 2 minus 1, because the base value of binary number system is 2. So the r minus 1 is nothing but 2 minus 1. It is known as 1's complement, and the r's complement is known as 2's complement. So for similarly for the rest of the two number system, that is for octal numbers, the r minus 1's complement is nothing but 7's complement, and r's complement is nothing but 8's complement. So similarly for hexadecimal number system, it is 15's complement and 16's complement. So likewise, for every number system, we defined two different type of complements. One is called r minus 1's complement, another one is the r's complement. So if the number system changes, the r value is also changes. So that for decimal number system, it is known as 9's complement and 10's complement. For binary number system, it is known as 1's complement and 2's complement. For octal number system, it is known as 7's complement and 8 complement, and for hexadecimal number system it is known as 15's complement and 16's complement. So in further classes we concentrate on only two types of number systems, that is decimal numbers and binary number systems. We identify how to calculate these two types of complements for decimal numbers and binary numbers, and at the end we will observe how do we perform subtraction between two decimal numbers or between two binary numbers, either by using this r's complement or r minus 1's complement. So that's the use and that's the type of the complements we have. There are two important uses. First thing is it is used to represent the negative numbers, because the digital circuit cannot understand sign. For that reason only we required a separate format for the representation of negative numbers. And the second important use of this complements is it is used in subtraction operation. We already observed the example of a minus b, right? That means by using addition we obtain the result of subtraction. So these are the uses of complements and these are the types of complements. And let us see how to calculate, and we have a general formula for this complements, and let's see those well. So let us see how to calculate the first complement, that is diminished radix complement, also known as r minus 1's complement. For this, let us assume a given number n. Capital N is a number in base r, small r is the base of that number, and having small n number of digits. So we assume a general number n in base r having small n number of digits. So then the r minus 1's complement, of then the r minus 1's complement of n is given as r power n minus 1 minus n. So this is the general formula where my small r indicates the base of the number system. So if the number system changes, the base value is also changes, and my small n indicates the number of digits in that number, and my capital N is my actual number, right? So for example, if you consider this r minus 1's complement for decimal number systems, for example, for decimal number systems, so for a decimal number, this r minus 1's complement of n is nothing but 10 minus 1, that is 9's complement of n is given as, so the small r is nothing but the base. So the base of the decimal number system is 10. This is nothing but 10 power n minus 1 minus n. So this is the formula for finding the nines complement of a decimal number system, or there are diminished radix complement of a decimal number system, or the r minus 1's complement of a decimal number system. So let us see what about this 10 power n minus 1 indicates. So actually the 10 power n is nothing but 1 followed by small n number of zeros. So that is what, if I say 10 square, that is nothing but 1 followed by 2 zeros. In similar manner, 10 power n is nothing but 1 followed by n number of digits, or n number of zeros. So in similar manner, this 10 power n minus 1 is nothing but, so small n number of, small n number of nines, because 10 power n is 1 followed by n zeros. So if you subtract a 1 from that, that gives you n number of nines. So that means if you want to find the nines complement of a number, you can see this 10 power n minus 1 is nothing but, so this 10 power n minus 1 is nothing but n number of nines. So the in from that n number of nines, I am subtracting my actual number. So that is nothing but, finding the nines complement is nothing but subtract each digit from 9. So if a decimal number is given and been asked to calculate the r minus 1's complement, you can find by using this formula, that is 10 power n minus 1 minus n, or in shortcut or in simply you can do that, subtract each digit from 9. So that also gives you your nines complement of the decimal number. In a similar manner, we can find the r minus 1's complement for binary number system as well. So let us consider a number n in base 2, because the base of the binary number system is 2 with small n number of digits. Then the r minus 1's complement is nothing but 1's complement, because r value is 2, r minus 1 is 2 minus 1, that is 1. So the 1's complement of n, so where n is my binary number, so the ones complement of n is given as 2 power n minus 1 minus n. So in general formula, it has r power n minus 1 minus n. So the r indicates the base of the number system. For binary number system, the base is 2. For that reason only 2 power n minus 1. So here also the 2 power n is equal to 1 followed by 'n' number of zeros. a 2 power n is nothing but 1 followed by n number of zeros in binary. So in similar manner, 2 power n minus 1 gives you so small n number of ones. So if you subtract a 1 from 2 power n minus 1, that is equal to n number of ones. So we can say that 2 power n minus 1 is nothing but n number of ones, and if you want to find the r minus 1's complement, subtract the n. So that is, in general, you can do that. So to find the ones complement of a binary number, subtract each digit subtract each digit from 1. So that's the shortcut. So either you can find the r minus 1's complement of a given binary number by doing this formula, that is 2 power n minus 1 minus n, or you can find it by a shortcut subtracting each digit from 1. So let us see some examples to find the 9's complement of a decimal number and 2's complement of a 1's complement of a binary number by using the formula and by using the shortcut. For example, let us consider an example. Find the 9's complement, that is nothing but r minus 1's complement of a decimal number 25. So here the number is 25. That means my capital N value equal to 25 and my small n value equal to 2, because the 25 is composed of two digits. It is having two digits, so the n value is 2, and we know the small r value for a decimal number system is 10. So if you're using the formula, that is nothing but the 9's complement of n equal to the 9's complement of, so here n is nothing but 25. The 9's complement of 25 equal to 10 power n minus 1 minus n. This is the actual formula. So because the small r value is 10, so this is 10 power, thus my small n value equal to 2 minus 1. So 10 square minus 1 minus 25. So my 10 square is nothing but 100. 100 minus 1 equal to 99 minus 25. So if I do this one, 99 minus 25, this is equal to 9 minus 5, that is equal to 2, and 9 minus 2, that is equal, 9 minus 5, let me erase this. So, so my 9 minus 5 is 4 and 9 minus 2 is 7. So this is what the 9's complement of my given number. So this can be done by using the formula. In other words, we said to find the 9's complement of a given number, so that is my 25. So the 9's complement is subtracting each digit from 9. So that is subtract 25 from 9, each digit from 9. So if I do so, 9 minus 5 is equal to 4, 9 minus 2 equal to 7. So that's what we get. Either you can substitute in the formula and simplify it and find it, or in shortcut form you can subtract each digit from 9. Let us take another example. So if you see the example 2, find the ones complement of a number 1010. So here 1010 is a binary number, right? So we asked to find the ones complement, that is nothing but r minus 1's complement of a binary number. So here my capital N equal to 1010 and my small n equal to 4, because it has 4 bits or 4 digits, and my small r equal to 2 because it is a binary number. So then my ones complement, so my ones complement of n, that is nothing but 1010 is equal to r power n minus 1 minus n. This is the general formula. If you substitute all the values, that is by small r equal to 2. So 2 power 4 minus 1 minus 1010. So as we said, 2 power 4, actually if you calculate 2 power 4, that gives you 16, but you need to convert that 16 into binary. So that is 1 followed by 4 digits. So 2 power 4 is nothing but 16. If you convert 16 into binary, if you convert your 16 into binary, that is 1 followed by 4 digits. So if you 1 followed by 4 digits minus 1 gives you 4 ones. That is what we explained in previous one. 2 power n minus 1 gives you n number of ones, minus 1010. So that is, if you subtract, you can see 1 minus 0, 1. So 1 minus 1, 0. 1 minus 0, 1. And again 1 minus 1, 0. That is 0101 is the ones complement of the given 1010. This is by using the formula. In other words, you can say by the shortcut, you can subtract each digit by 1. You can subtract each digit from 1, or you can also do invert each digit. Invert in the sense changing zeros into ones and ones into zeros. That gives you your ones complement as well. So this inverting is nothing but subtracting each digit from 1, you can see. So if I say 1 minus 0, it gives you 1. I subtracted a 0, it becomes 1. If I say 1 minus 1, it is 0. I subtracted a 1, it changed into 0. So inverting zeros into ones and ones into zeros is nothing but subtracting each digit from 1. So by this shortcut, the given number is 1010. If I invert each digit, so my first MSB is 1, so it is 0, it is 01. So that is what my 0101. So either you can find the ones complement of a binary number by using the formula, or you can find the ones complement of a binary number simply by inverting each digit, because in binary number there is only 2 digits. So inversion in the sense changing the zeros into ones and ones into zeros. So in that way you can find the ones complement of a binary number as well. So now we will see the second type of complement, that is called a radix complement. So how to find the radix complement for decimal number systems and for binary number system. So for a decimal number system, the radix complement forms the tens complement, and for binary number system, the radix complement or ours complement forms twos complements. So let us see how to calculate those values. So let us see how to calculate the second type of complement. It is known as a radix complement or R's complement. Right? So for this, let us assume a general number n, a number n in base R having small n number of digits. So what we actually assumed for R minus 1's complement or a diminished radix complement. So in this case, the R's complement of n, the R's complement of my capital N is equal to simply R power n minus 1. So this is what my R's complement, right? So this R's complement, it can be slightly modified as follows. So the complement is R power n minus n. So this can be slightly modified as R power n minus 1 minus n plus 1. I simply subtracted a 1 and added a 1. So there is no change. This minus 1 and this plus 1 get cancelled and the equation remains 1. We already know the value of this. So this is nothing but r minus 1's complement plus 1. So that means my r's complement is nothing but r minus 1's complement plus 1. So whenever I want to calculate my r's complement, simply I find the r minus 1's complement of the number and then add a 1. So if you apply it for decimal number system, that is nothing but my tens complement. So my tens complement is equal to r minus 1's complement plus 1, that is nothing but my nines complement plus 1. If I apply it for binary number system, that is my 2's complement, it is equal to my 1's complement plus 1. So this is how you can find. You can find by using the formula, that is r power n minus n, or you can find by finding the diminished radix complement first and adding a 1 to it. So let us see with one example how to find this radix complement for both decimal number systems as well as the binary number systems. So looking into the example 3, so in this example, find the tens complement of decimal 45. So keep in mind that for decimal number systems only we can find the nines complement and tens complement. So for the binary number system, it is ones complement and twos complement. Sometimes I say find the find the tens complement of a number so and so, that number must be a decimal number, right? So now see how to find the tens complement of a given number. We already know that the tens complement of, so the tens complement of my 45 is equal to the nines complement plus 1. This is how we will do. Or we have the alternate one is to substitute in the formula, that is r power n minus n, that is 10 power n minus n. So that is also one way, but this is the simplest way. First find the nines complement of a given number and then add a 1 to it. So we know how to find the nines complement of a number. Subtract each digit from 9. So that is nothing but 99 minus 45. This is how we will find the nines complement and adding a 1 to it, right? So if I do so, so this is 9 minus 4, I will get 5. 9 minus 4, I will get, sorry, 9 minus 5, I will get a 4 plus 1, which is equal to 55. So this is how we will find the tens complement of a given number. And there is a one shortcut for this. So the shortcut is very simple. So first subtract the first non-zero digit. The first non-zero digit from 10. Subtract the first non-zero digit from 10 and the rest of the digits from 9. So this is the shortcut. So for a given number, subtract the first non-zero digit. If there is a 0, you leave it as it is. So let us see with an example. So given 45. So in this 5 is the first non-zero digit. So subtract this 5 or the first non-zero digit from 10. So 10 minus 5 is the 5, and the rest of the digit, there is only one digit left, that is the 4. Subtract this 4 from the 9, that is 5. So this is how you can calculate the tens complement directly. So if I see one more example, if I want to calculate the tens complement of a number 120. So in this case, the first digit is 0. This is not a non-zero digit. This is a 0. So I leave the 0 as it is. And next, my 2 is the first non-zero digit. So I will subtract this 2 from 10, that is 8. And the remaining digits from 9. There is only one digit. So 9 minus 1, that is 8. So my 880 is the tens complement of my 120, or you can verify it by finding the nines complement plus 1. So this is how you can find the tens complement of a number. So similarly, we can find the twos complement of a binary numbers as well with an example. Let us see that. You can see in this example 4, we've been asked to find the 2's complement of a binary number 1010, right? So the 2's complement of 1010 is equal to the 1's complement of 1010 plus 1. So the r's complement equal to r minus 1's complement plus 1. And similarly, the 2's complement equal to 1's complement plus 1. And we already know how to find the 1's complement for a binary number, simply changing the zeros into ones and ones into zeros. So the 1's complement of 1010 is 0101 and a plus 1, add a 1. So 1 plus 1, that is 1, 0. So 1 plus 0, 1, and the 1 remains as it is, and 0. So that is 0110 is the 2's complement of 1010. So this is how you can do by finding the 1's complement and adding 1, but there is a shortcut as well. So in the shortcut, so the shortcut is very simple. Keeping the first one as it is and inverting the rest of the digits, and inverting the rest of the digits. Keeping the first one in the sense not the first number, first one. So let us see with an example. Let me scroll down. So let us see with example. Same example we took 1010, right? So to find the 2's complement of this number, keeping the first one as it is, you can see first there is no one, first there is a digit. First there is a digit 0. So this is not the first one. My next digit is the first one. So this is 0. Keep the 0 as it is. Keeping the first one as it is. This is my first one. I write down my first one as it is and inverting the rest of the digits. That is 0 is inverted into 1. 1 is inverted into 0. So that is what? 0110 is my 2's complement of a given number. In other words, you can see find the 2's complement of 1101. This is the given number, right? So in this case, keeping the first one as it is, if you observe the number, this is my first one. Keeping the first one as it is and inverting the rest of the digits. So this is 0, invert to 1, this is a 1, invert to 0, this is a 1, invert to 0. Right? So this is how you will find the 2's complement of a number. So there are three alternatives to find the 2's complement. First one is by using formula. The first one by using the formula, that is r power n minus n, that is the one. And the second thing is by using 1's complement plus 1, and the third one by using shortcut. So there are three alternatives to find the 2's complement. Similarly, there are three alternatives to find the tens complement as well. You can find the tens complement by using the formula, or you can find the tens complement by finding the nines complement and adding a 1 to it, and you can find the tens complement by using the shortcut, that is the subtracting the first non-zero digit from 10 and rest of the digits from 9. So this is how you will find the complements of your both the number systems. Either it is a decimal, you will find the nines complement and tens complement. If it is a binary, you will find the ones complement and twos complement. So that's all for this class. In the next class, we will see how the subtraction is performed by using these complements. Thank you.